Hello and welcome to episode 2 of SAS From Scratch. So in the previous episode I said we would have fewer slides, not no slides at all. So we will be looking at some slides today first, and then we'll start also looking at some SAS syntax. We'll write a bit of code and we'll do a very simple exercise towards the end. Without further ado, let's get started. So there's two types of statements that you'll find in SAS. The first is a global statement. The second is statements of limited scope. And so your limited scope statements are data and proc statements. I've highlighted them in bold because those are the ones that you're going to encounter most often. Most of your program is going to consist of data and proc statements. We'll talk a bit more about the options statement today. We'll just briefly cover it. The libname statement we'll do in the next episode. And titles and footnotes are further down the line, so we're not going to worry about them too much. Something that we will be looking at today is to better understand what a SAS library is. We're going to look at this again in the next episode as well, except next time we will be creating libraries of our own and not just working with the built-in or default libraries. So first of all, let's look through the formal definition of what a SAS library is. It's a collection of one or more SAS files. This includes your SAS datasets that are referenced and stored as a unit. In a directory-based operating environment, a SAS library is a group of SAS files that are stored in the same directory. And so what's the gist of this is trying to say that a SAS library, for all intents and purposes, on Windows or Unix or possibly Mac, refer to a folder. It kind of references a folder, and within that folder there will be format catalogs, there will be datasets, etc. It's a little confusing in this definition when they speak of a directory-based operating environment. They are talking about Windows or Unix versus ZOS. So something that you will see in your base prep guide is they will compare Windows and Unix environments with the ZOS environment. To my knowledge, that's just for background. I don't think you need to know too much about ZOS for the base exam. But it is still good to know between these different operating environments how SAS will behave. So in a nutshell, you can see a library as a folder, but the formal definition is more than that. It's a collection of SAS files that are stored in the same directory. SAS datasets are referenced by a two-level name, so you will always have you'll have a dot in between. Your first part will be the library where the dataset is stored. The second part after the dot will be the actual name of the dataset. If you do not specify a library, then SAS will assume that you are referring to the work library. You'll hear about the work library a lot. That's a temporary library. It's there by default when you start your SAS session. So you don't have to worry about assigning any of that stuff. There's 3 default SAS libraries depending on your SAS installation, depending on how your SAS administrator has set up your installation or your server. You may see more. You may, for example, see a maps library or something else. The 3 that you will always see, I'm going to start with the last one there, the work library. Again, it's always there. It's temporary. And if you don't specify a different one, this is assumed. So we'll take a look at that in the code very soon. But essentially, if you just write a dataset name and you don't prefix it with a library, that dataset will go to the work library. This is temporary. The files you store there are lost as soon as you close your session. And if you want to preserve the datasets you've worked on and the output you've created, you'll have to specify a non-temporary library. I think the text there is not completely correct. Sorry about that. So it says a temporary library file. It's not a file, it is a library, which is a reference to a folder basically. So that word file just needs to be removed from the work bullet there. Then there's two other ones. I'm not going to bother too much with the SAS user. You should know that it exists. We're not going to be fiddling with that. The main one, which is important, is one that's called SAS Help. That contains sample data. We will be using a lot of the sample data. We'll be using one of the data sets from the SAS Help library today to do an exercise. And it also contains other helpful files like dictionary views. You don't have to worry too much about the dictionary views right now. Be aware that they exist. They are extremely useful, but we don't have to stress about that too much. And then the last note there, the last bullet point, go through the SAS prep guide. Make sure you understand how Windows and Unix differ from ZOS, and check as well how they handle libraries between the two of them, because they do differ. I cannot remember if this is a question that comes up in the base exam. It very well might. So this is important. I'm going to switch to SAS Studio, and we can quickly take a look at the default SAS libraries and where you can find them. This is what SAS Studio looks like as soon as you log in. This is SAS On Demand for academics that I'm using, and the default interface is SAS Studio. If you're working with Enterprise Guide, or if you're working with the SAS windowing environment, it'll be very similar, just not exactly the same. So as soon as you log in, you'll get a blank program here. We can close that for now because we're not gonna use it. So here on the left hand side, we've got server files and folders. This is where you will be storing things. You can create folder shortcuts. A folder shortcut and a library are not the same thing. You can, so here, this is a very restricted file or directory listing, because this is on SAS Studio, on the SAS servers, the academics one, so you won't see all of the file system. Normally, if you were maybe using it on your academic institution server or on the server you have at work, you would probably see a bunch more directories here that you have access to. The access is very restricted here. So this is a folder I've created that I've put some files in to test with. We'll create a folder later as well. So that's where your files and folders go. If you move down, you'll see there's an item here called Libraries. I'm going to click that so that it opens. I'm going to expand the My Libraries item. And you will notice there's the work library. This should be empty. It is. There is a SAS user library. This is also empty. And there is a SAS help library, which is not empty. So within this SAS help library, there's a bunch of sample files, as I've said. You can double click these to view them. So for example, if we want to look at air, which I believe was an air quality index table, that's from January 1949, and I think they collected it over, there's 144 rows. SAS only displays 100 rows at a time, so we'll advance to the next one. I'll scroll all the way down. So they've got it from 1949 until 1960. There's an air quality index. There's an airline dataset, for example. I can't remember exactly what this one was meant to be used for. The one we'll look at a lot is cars, because it's easy to work with, it's easy to understand. And later today, or later in this episode, we'll also look at the fish dataset. And you'll notice as I start opening up, as I double click these datasets and they open up, you'll notice they open as new tabs here at the top. So I'll close them for now, we won't need them. And if I want to go back to where the server files and folders are, I simply click it in this list above. So most of the time while you're navigating SAS Studio, it'll be between server files and folders and this libraries tab. Okay, back to the slides. We're already at slide 4 out of 10. There's not too many here. The important thing to keep in mind while you're working with SAS is the rules for naming things. So there's 3 things that we would normally name. The first is datasets, obviously. They have to begin with a letter or an underscore. They cannot start with a number. They cannot have a dot or a hyphen or any of that. They have to begin with a letter or underscore. After the first character, you can add numbers into that as well. And your dataset names have to be 1 to 32 characters in length. Libraries have the same rules, except your library name has to be 1 to 8 characters in length. You'll notice if you go back to the Libraries tab in SAS Studio and you click on, if you view them, SAS Help, that's 7 characters, SAS User is 4, Work is 4, you'll notice that pattern throughout. For variables, it's the same as datasets. Have to begin with a letter or underscore. Thereafter, any combination of letters, numbers, or underscores, and also 1 to 32 characters in length. You'll notice next to the libraries bullet point, I have in italics there, I have compatible, and next to the variables bullet point, I have v7. That fits in with the bullet item at the bottom, where you can change the rules for naming things. So for variable names, you would change the valid var name option from, I believe the default is v7. You can change it to uppercase, which will be the same as v7, except that you would have all of your variable names will be uppercased. I can't remember if SAS forces it to uppercase or whether you have to make sure that they are. Otherwise it will say it's not a valid variable name, possibly. There's also valid var name equals any. I do not recommend using these options. They will give you a lot of headaches down the line. They will give your fellow programmers, if you're working in a team, headaches down the line. But if you absolutely have to use them, changing valid var name to any will allow you to have spaces in there, will allow you to have blanks in there, etc. But it's not recommended. Valid mem name is for your I think that's not applicable to libraries, it's applicable to datasets. So I've got an error in the slides. So this bit here that says compatible should be next to the datasets item. And valid mem name is for your datasets. So you can change that from compatible, which is the default, to extended. That also allows, it gives you a bit more leeway in the naming of the datasets. SAS is a bit more lax when it comes to that, but again, it's not recommended. It will give you headaches down the line. It's not the conventionally accepted way of doing it. and try to avoid it as much as possible. If you want to just have an idea of how you would do something like that, I'm quickly going to click, let me do that slowly. If we go to this button up here in the top left with it's like a little folder or a page that has a little asterisk next to it, and we click that and we say we want a new SAS program, you would basically execute that with an options statement. So you could say options valid var name equals v7, and that's how you would execute that. You would normally put your option statements at the top of your program. Your options, when you create a library of your own, you'll put that at the top, and your data and your proc statements will follow below. And as we've said, your data and your proc statements will basically make up the vast majority of your program. I'm going to take this out for now. We're not going to bother with this. Sorry. And just go through the prep guide, make sure you understand the differences between all of these different rules for naming things. They are important for the SAS base exam. Basically, if I've got something in these slides, they're important for the SAS base exam. Okay. Other things to keep in mind when you're dealing with SAS variables is that they are not case sensitive. Person underscore name all lowercase is the same thing as person underscore name all uppercase. That goes for everything that's in SAS. That's going to hold true for your code, your dataset names, your library names, everything. So none of that is case sensitive. The only time you'll start dealing with case sensitivity is if you're specifically testing whether a certain variable, let's say you've got a character variable, so it's a string, if that is equal to something that's in quotation marks. So that is case sensitive. So in that case, if you've got somebody's name, for example, Charlie, and the C in Charlie is uppercased, and you're trying to match that with something in a variable, that case will matter that'll be case sensitive. The other important thing to keep in mind is that SAS only has two data types. Something is either character, a string, but we call it character, or it is numeric. So character it can be a single character, it can be a series of characters, i.e. strings. That's something that goes into quotation marks. Can be single quotes or double quotes, and at some point we will talk about the differences between single quotes and double quotes, but that is not important for today. The other type is numeric. That's your numbers. That can be integers, it can be floats or doubles, or basically anything that's not, if it's not a character, it's going to be a number. But we do not distinguish between the different types of numbers. So we don't have, for example, as in R, you're going to have integer types and doubles and floats, and you will have specific types for dates and times. That does not exist in SAS. So if you've got a date, for example, that'll be, so if we're only dealing with a date and not date time, if we're dealing with a date, that's going to be the number of days since the 1st of January 1960. So I think Unix time, the epoch or epoch, however you want to say it, is from 1970. That is not the case in SAS. It's from 1960. And if you create a date in SAS with the MDY function, which we're not going to talk about today, I'm just trying to give you some background, and you say, okay, well, create for me a date. It's the first month and the 15th day of 2020. What you're going to get back is, I think it'll be about a 5-digit number, and that's the number of days that has passed since 1st of January 1960. And that number will always persist throughout your dataset. If you want it to appear as a date, SAS has something called formats that are layered on top of the underlying numeric values. So if you're doing dates, if you're doing currencies, if you're doing dates and times, if you're doing clock times, any of that kind of thing, you can make it appear like a date or a currency format or whatever it is. But as long as that stays a number, as long as you don't convert that to a character, you will always have a raw number value underlying that. And we will, in future topics or sessions, we will talk about formats, we will talk about converting from number to character and character to number and vice versa. That also works a bit differently from what you might be used to. But for now, as long as you keep in mind that something is either character or numeric, no matter what, then you'll be fine. It'll make a lot more sense to you. And again, as I've said, if you're working with a date, keep in mind that date is just a number with a nice looking format plastered on top of the number. But under that format, it'll always be a number. Okay, then let's look at the different parts of a SAS dataset. This image is not my own. It is in the SAS certification prep guide in my copy of the 5th edition. It can be found on page 16. These episodes should match 1-to-1 what you find in your prep guide. So this is episode 2, chapter 2 of the prep guide. Maybe you've got a different edition, maybe it's a couple of pages back or forward, but you'll find this in chapter 2 and you'll find it with a good explanation as well. There's a few parts that a SAS dataset has. We'll come back to the descriptor portion. It's very important. For now, we can look at the data portion. It has observations or rows. It has variables or columns. So obviously your rows run horizontally, your columns run vertically. And this is pretty much the same as what you would see as if you had an Excel sheet or something open. So you have a bunch of cells and they're organized in rows and columns and they have values in them. Indexes we're not going to worry about for now. We will not be using them for now. They are considered an advanced topic. So if we ever get to a series for advanced SAS topics, then we'll talk about indexes. We're not going to do that now. We're not going to worry too much about the extended attributes at the moment either. It's good to read about it in the prep guide. The important thing that I want to focus on for now is the data portion and the descriptor portion. And so the descriptor portion has some metadata in it about your dataset. So it'll have the name of the dataset in there that you've given it. It'll have the date and time of when the dataset was created, how many observations are there, how many variables are there. It'll contain metadata about your variables. So it will say, okay, well, this column has this name and it's this type, it's character or it's numeric. Again, there's only 2. This is the length of that column, i.e. how much space is reserved for that column. And that's another interesting thing that SAS does, is that you need to reserve space for something. So if you're dealing with a character variable, for example, and you reserve, say, 10 characters, and the text that's inside that variable is 12 characters, you're going to truncate the last 2 characters off from there. So it's important as well to make sure that your lengths are optimal. Conversely, if you go ahead and say, oh, well, I'm just going to make everything length 100, even though they're probably only going to be about 10 characters, the actual values, then what SAS does is it reserves 100 bytes, and you'll create big data sets with a lot of wasted space in there. So you've got to make sure that you get the lengths correct. And that's just, I think, part of SAS being an older language. It's one of those quirky things that you need to get used to. Next up, it will capture whether there are formats or in formats, and we'll talk about those. As we've said, in a later episode, we'll cover that. But as we've said, a format is basically something that's plastered on top of a value to make it look nicer. It makes a date readable, it makes a time readable. We'll put a currency sort of decoration on a number, etc. And then the other thing that SAS adds to variables are labels. And that's something we can look at in SAS Studio as well. I'm not sure if the sample datasets really do that sort of thing. But SAS variables have both names and they have labels. So the names are how you refer to those variables, but the labels decorate those columns with something that's more informative, maybe has spaces in there, or just explains what's actually going on in that column. And so if you open a SAS dataset, you can choose, do you want to view it with names or do you want to view it with labels? And that helps you navigate the dataset as well. The other important thing that SAS does is that it knows how many rows and columns it expects in a dataset. So if a dataset accidentally gets damaged while it's being transferred, or somebody has maybe tampered with it and deleted some rows or something from it, when you try and open that dataset in SAS, it'll give you a warning that says, look, SAS will tell you, look, I've looked at the descriptor portion. I expected there to be 1,000 rows, but now there's only 998 rows in here. And that gives you doesn't give you a good indication. It tells you, you know for a fact that something has gone wrong with this dataset. And you should be checking with your vendor or whoever the supplier was of that dataset to have them resend it to you and check what went wrong. So they're very, very versatile and useful datasets. The only thing to watch out for is when we talk about a SAS dataset, we're referring to a SAS7bdat file. It's a very long extension, .sas7bdat. Those are proprietary formats. So if you're dealing with R, the Haven library will allow you to read them. There's a read, I think it's read_sas is the function. Don't think it's read.sas, I think it's read_sas. But it is still a proprietary format. If you are transferring datasets, it is much better to be using the SAS transport file format. That's your XPT files. It's an open source format, and it's also better to work with because they're platform independent. So a SAS dataset captures certain things as well. Is it a 32-bit or a 64-bit system? What encoding is it being used on? And it sort of tries to optimize for that. But that also means if you move it from, say, a 32-bit Windows platform to a 64-bit Unix platform, it should work, but it'll complain about that. So the XPT files are much better if you actually want to transfer data between two different vendors or parties or whatever. Okay, let's talk about SAS syntax and good programming practice. We'll start typing some code pretty soon, and you can see some of that in action. We've already mentioned SAS is not case sensitive, except in the case where you're checking whether one string is equal to another string. But your code, your dataset names, all of that stuff is not case sensitive. A line of code will always end with a semicolon. You can wrap lines, and then only where it's supposed to end you can put a semicolon. While you don't have to do this, and we'll look at an example of this, your data and your proc statement, so that's the things that your data steps can manipulate data, add new columns, change existing columns, etc. And your proc statements, they will either analyze data or they can sort it or do something else with it. Those guys are supposed to end with a run statement. There's certain procs like proc-SQL that will end with a quit, but the good programming practice is to end each of these with a run statement. If you don't, so if you start a data statement, you type some stuff in there, and you then move on to a new data statement or a proc statement, SAS will automatically infer that there should be a run there, but it's considered bad programming practice. So it's good to get into the habit of doing that yourself. It makes your code look cleaner. It makes it more readable, and it comes down to also having some pride in the work that you do. To not just be sloppy about it and messy about it. Indent your code to make it readable. There's different ways that people indent their code. Some people do things a little differently from others. At the end of the day, my personal view on it is that as long as you are going through the effort to indent it, as long as you try to make it as readable as possible, there will always be small differences in how people do things. But again, it comes down to having some pride in the work that you do, and keeping it neat and tidy. Make sure your variable names are descriptive. So you've got 1 to 32 characters. You don't have to use all 32 characters, but don't call a variable X or A or a random bunch of characters. Give it a name so that people can actually figure out what it does. Add comments to your code. We'll look at how you can add comments. There's about 3 different ways that you can do it, if I remember correctly. And the other thing is to not continuously overwrite datasets. So good programming practice in SAS is that you can sort of run a data step or a proc or whatever it might be by itself without having to step back to previous steps. So I've noticed, for example, in some R code, you would use the, and again, I'm going back to R. If you're not coming from R, or you're not interested in R, just blank out the next minute or so of me talking. If you use the Magritter package and you use that double pipe that goes back and forth, you can sort of start with a data set. You can do stuff and then put it back in the same data set. That's not something that's considered good programming practice. In SAS, what you would have is you would have different data sets that follow from one another, maybe use each other as input, but then write out to another differently named data set. So that if let's say you have, and this is bad naming, but let's use it as an example, data 1 that reads from somewhere and does something. You would then make data 2 that reads from data 1. And so if you fiddle with something in data 2, it'll just read from data 1 and go through that again. If you do data 1 and then you do data 1 again, in your code, you'll replace that and you'll need to start from the top again to make sure that they follow along properly. So we don't overwrite data continuously in SAS like you might be doing in R. I've seen it happen in R. I don't know if it's considered good practice. It might be, especially because R loads data sets into RAM by default, whereas SAS would put it into storage. So SAS optimizes things. It'll load some stuff in RAM. It'll do stuff, but for the most part, the way SAS works is to store it somewhere on a disk, and then it'll read line from line. But there will be optimization. So in theory, that's what SAS would be doing, but SAS optimizes a lot of stuff as well. If you wish to strictly adhere to good programming practice, and this is something that I don't do myself, but you would capitalize your SAS keywords. So if you write data or proc or run, that'll be capitalized. Sorry. And then the next one will be an exercise, but let's first go to SAS Studio, and we can put in a bit of code and we can play around with it for now. So the first thing I want to do is I want to make sure I'm looking at server files and folders. I'm going to right click here on my home directory and I'm going to create a new folder. I'm just going to call it, apologies if the keyboard is a bit loud, I'm going to call it SAS From Scratch. And then there's nothing in this folder. I'm going to right click on it and I'm going to say new SAS program, and I'm going to save it immediately so that it's in there. So I'm going to click the save button, which was up here. I'm going to go to SAS From Scratch and I'm going to just call this episode 2. And I guess let's be neat and tidy about it. So in your SAS program name, that's the same as any other file name. That's either on Unix or on Windows. You can put spaces and numbers and whatever in there. It's just a plain text file. So the way that a SAS program would normally run is we would be working with data and proc steps. For example, if we want to load in some data about cars, we could say, okay, data my cars. Again, notice the semicolon. Where's that data coming from? We're doing that with a set statement, and we're reading in SASHELP.cars. Now, just as a reminder, if you go on the left here to your navigation pane and you click on libraries, you will see that within the SASHELP library there is a dataset called cars. We can double click it and we can see some information about cars. So there's Acuras, Audis, BMWs, etc. Makes, models, types, etc. All of that is there. And so what this code does is this data step with a name is what's going out. So what we want to do is create a data set that's called my cars, my underscore cars. Because we're not specifying a library, we remind ourselves that that will go to the work library, which is in here. And that is currently, I'll refresh it for you. That is currently empty. There's nothing in there now. But once we run this, there will be a data set in here called my underscore cars. And it will be an exact copy of SASHELP.cars. And so you would have something like this throughout your SAS program, because you'll import data, you'll edit it, and you'll export it somewhere else. I'm going to run this. I'm going to not put a run statement in here, just so that you see that it will still run, but keep in mind that this is bad practice. And as soon as we run this code, we get a few different things here at the top of the tab. So we're still busy with our program, which is episode2.sas. This was our code. We hit the run button, and there's no errors or warnings, which is why, and we'll see an example of an error or warning as well. But that's why it takes us directly to the output data. And this is the exact same data that you'll find in SASHELP.cars, except it now exists in the work library, as we expected. We could also have manually typed work.mycars. It would have done the same thing. And I'm just going to put a run statement here because it annoys me when it's not there. So we can run that again. We've now put a library in here. We forced work dot, but it would have taken that anyway if we didn't specify it. And I've added a run statement here because it's good programming practice. So if you wanted to be, strictly conforming to good programming practice, it would look like this. Not too many people, at least in my experience, stick to that. Then there's a few other, I'm going to close this original one here. There's a few other tabs we need to look at. Results we're not going to worry about too much. In the next episode, which will probably be released next weekend sometime, we'll look at the results tab. So this is specifically if you don't have, if you've got something like a proc contents that tells you about the contents of a library or dataset. If you do a proc print, which prints in a nice format the data set to sort of, whether it's HTML or PDF or whatever you want, or if it just outputs it to the results tab, that's something that you would see in there. So that's specifically when we're not looking at the data set, but maybe a processed or printed or decorated version of a data set, or it could be some other proc that has analyzed something and is now providing us with statistics or other information. That'll go here in the results tab. The one that is one of the most important is the log. The log is really useful. So here you will see an option statement. We didn't put that in there. That's just part of the setup that is part of SAS Studio when you're using SAS on demand for academics. So this is a default option statement that will run every time. And then here's the code that we ran. So you can see data work.my.cars, set SASHELP.cars, and then we closed it off with a run. SAS will, for each of these statements, give you some information. So in this case, it gives you how much time and CPU time and memory and whatever this specific statement used. And then at the end here, there's another option statement which is the same, but this is just part of the environment if you're using SAS for academics. And the idea would be then that you could, well, it's not just the idea, it's how your programs work. You would basically sort of daisy chain things from your input data. So in this case, our input data was SASHELP.cars. We put it into a different data set. We can now use that data set in a new data step, or we could pass that to a proc so that we can sort something or we can analyze something. And so what we can test out an example of that. For example, we can say, okay, well, let's go and look at our data and see what we can do. We've got engine size, we've got cylinders, we've got horsepower, we've got weight. So let's see if there's something that we can calculate specifically. But it might not even make a lot of sense. We can maybe let's do something like cylinders times engine size. Just as an example. So we can start a new we can make a new column. We can call it let's call it silly column, and we can multiply a bunch of stuff together here that doesn't even make sense. So let's say engine size times cylinders times horsepower, and you'll note that here we've got engine with a capital E and size with a capital S. So I will on purpose make everything lowercase in the code just to show that the case sensitivity does not apply. And then I want to also draw your attention while we're in the output data tab. You'll notice there's little symbols here next to the columns. We can click on each column and you'll see that label and name are the same, except for example for mpg_city. So how many miles per gallon do you get in the city? The name has an underscore because that's a legal and valid name. You can't put a bracket in there. But the label will appear as miles per gallon brackets in the city. And if we look at the highway, 1 miles per gallon to the highway. So there's an underlying name by which you would refer to the column. And then there's a label, which is how the column is displayed. If you were to output it maybe to a proc print procedure or something. So in the meantime, let's go ahead with our silly column. We're going to multiply engine size, cylinders, and horsepower. And that's simply going to be something, apologies, engine size times cylinders times horsepower. And if we run this, there's our silly column. And so I want to remind you again what we did in the previous episode. What's happening here is the PDV does it row by row, does this calculation, outputs that row, takes the next row, does the calculation, outputs that row. So we're not What's not happening here is what would happen in R, which is to take these columns as vectors and then multiply across that vector. So this is row by row that this calculation is being done. And we are not changing this underlying data set called SASHELP.cars. SASHELP.cars, if we go to our libraries, if we go to SASHELP and we open this data set, I'm going to scroll all the way to the end, there is no silly column. If we go to our work library and we open the mycars dataset, there's our silly column. So we have not changed the underlying SASHELP.cars dataset. We've created a new dataset with our data step. This is called a data step. The other one is a proc step. And we've only added the silly column in there. What we can do, we don't have to do this. So let's say, for example, we want to calculate half of the silly column divided by 2. We can put that in a new column called something. We'll make up a name. So the way we could do that was we could also do what's a good name for this? Let's call it funny column, and that is going to be our silly column divided by 2. Again, note that there's an exclamation mark, sorry, not an exclamation mark, a semicolon after each one. We could do this, and it would work. So there's our silly column, there's our funny column, which is half of the other. But instead, what I would like to do is take this out. I'm going to start a new data step. I'm going to call it mycars2. I'm going to put that run in there straight away because that's good practice. And what we're going to do is we're going to read in mycars. So what we're doing at the moment is we're creating a data set called mycars2. We did not specify any library, so it will go to the work library by default. And then we're telling it that we're reading in mycars, which is this data set we've just created. So because this exists in the work library, we expect to see that if we run this as is, it will come with all the columns and things that we've added straight away. So mycars2 will be an exact copy of mycars, and it will have that silly column as well. And so we're daisy chaining these data steps together as we add all the columns we need. So I'm going to run that. I'm going to run the whole thing. If we go to our log, there's work.mycars that we're running. There's the calculation for silly column. And it will tell you, we took 428 observations from SASHELP.cars. That was what was read in. And the one we wrote out, my_cars, has 428 observations and 16 variables as well. 16 variables. This one would have had 15 variables because we've added one. And so if we move further down the log, here's the next piece of code that we ran. So mycars2 is the new name, and we read that from mycars. You can see the same thing here. 428 observations were read from mycars, and mycars2 has 428 observations and 16 variables. Note that here, even though we didn't specify work here, in the log, SAS makes it clear that that's coming from the work library. Let's add our funny column. And that's just silly column divided by 2. I'm going to run that. And if you've got more than one data step here and you run the whole, so you can also just run a bit. And that's why it's so important to make sure that your data step names are different. So if there will now be 2 of these in the work library, but essentially if I wanted to just say, okay, well, I want this now to be divided by 3 instead of divided by 2, I should be able to just highlight this little bit and run the selected code. And so what that's going to do is it will only run this one. If you look at the log, that's the only thing that's happened is we ran mycars2. And that's still reading the input from my cars. Why? Because that already exists separately in the work library. It's not permanent, but as long as my session remains active, this data set is in the work library. And so if I made a mistake here, if I put something silly in, like I don't know, let's do something like this. Let's introduce an error so that we can see what that looks like as well. So if I do something silly like this, and notice that there's a red cross, which means that an error has occurred, and we need to look at that. Ideally, good programming practice is that your log is free of errors and free of warnings. You don't want uninitialized variables floating around. Code should be clean. Everything that needs to be in there should be in there. If something shouldn't be in there, take it out. Again, that's part of taking some pride in your work and making sure that it's clean and tidy and correct. So these errors can be a bit cryptic to a newcomer, but it does tell you, look, this little underscore points to where it thinks something went wrong. And so it's saying, look, I'm not happy with what's happened here. Now, with that error having occurred, my cars 2 will still be will be well, we've already put this in, right? So let's do this. Let's make this 4, because as you can see here, we've already divided by 3. It was successful previously. So if we run this, we've introduced an error, and we're saying, look, I want you to, ideally I wanted to divide by 4, but that didn't happen now. If I go and look at work my cars 2, it will not have replaced this data set. This still differs by a factor of 3, because it was not successful in interpreting this code. So it did not write out this data set. If I go and I want to simply change this, I don't have to go back and run this first bit. I run the second bit, and if I look at work.mycars2 now, this is divided by 4. So 1600 divided by 4 is 400. We do a quick desk check of the results, and we know it works. So that is important. Being able to just go to specific bits in your code and being able to rerun it. Ideally, this is much too verbose. If we just wanted to add an extra column, we would have put it in there, and we wouldn't have bothered with this. But the idea of this is that you would plug from one into the next step, etc., until you have the data set you're looking for. And it's up to you to organize these statements and these calculations in a way that makes sense, in a way that's readable and understandable. Let's look at columns, for example, comments, for example. So you have your normal slash asterisk asterisk slash. This is a comment. Here I calculate a silly value. And this is a multi-line comment. You can also, if you start with an asterisk and end with a semicolon, that'll give you a single line comment. So I can say, here I calculate a funny value by dividing silly value by 2. So that's another comment. You can see it's highlighted in green, and I don't know if it's still the case. At some point back in the day, you could do something like this, where if you started with comment, I don't know if it still works, but we can try it. Comment, here we calculate a funny value. I don't know if this one still works. It used to at some point in the past. Apparently it still works. So it ignored this row 79, and these other ones that we put in comments as well. We've gotten rid of, there's another thing we can talk about. We've gotten rid of the code that produces my underscore cars 2. However, this work library is not cleared every time we run the code. So this data set, as we had it before, is still in there. Once we close our SAS session and open it again, it's going to remove everything in the work library. And if we come back and run this program again, we'll only see my_cars in there. But for the moment, because we're calling this my_cars and we're doing both calculations in here, this data set that's stored here has both the silly column and the funny column. And that's the basics of, it's a very basic program. It gives you an idea of how SAS code looks and how it's written. There's a small exercise that we can look at as well. If you would prefer to do this exercise on your own, you can pause the video here and you can try it out first, and then you can come back and watch the rest of it. So the exercise we've got here, so we're in episode 2, so it's exercise 2.1. It's the first exercise of episode 2. Is we're going to read in the SASHELP.fish dataset, and we're going to call it myfish. So I've designed this exercise to be done step by step. So we can do this first bullet point, then we'll come back and we'll look at the next bullet point. So read in this dataset, call it myfish. We know how to do that. We start a data step, we give a name, what we want. We close it with a run because we are civilized people, and we set SASHELP.fish. If we run this, we can take a look at our fish data set. I'm going to slightly adjust the length here just so we don't have a scroll bar. So we have a species, we have weight, we have length 1, 2, and 3, and we have height and width here. So these are all of our columns. Something useful to note, if you look at these little icons, the A means it's character, 1, 2, 3 means it's numeric. Something else that SAS will do is it is left aligning the characters and it is right aligning the numbers, as we can see here. So there's also a quick way of checking what it is. And the reason why that's important is if length was, for example, a character variable, we would convert that to numeric. So I mean 23.2, you can still put that as a character, you can still put it as a string, but you would want this to be a numeric variable if you wanted to use it for any calculations. So we've been successful now with the first bullet point that it asked us to do, which is read in this data set and call it myfish. The second thing that it's asking us to do is to find the maximum length across length 1, length 2, and length 3, and then take that value and place it in a new variable called max length. So we can do that straight into this step. So we can say, okay, max length equals max of length 1, length 2, length 3. Now, if you were running this in R, you would have to use a group by or something, because otherwise it would look at all the values in that column. Let's remind ourselves again, because it's so important. The PDV means that we're looking at one row at a time. So if we execute this max statement, it's going to take that single row and find the maximum value across those 3 columns for that single row. So this max function, the min function, there's floor, there's ceiling, there's rounding, there's a bunch of different functions. We'll talk about them in future episodes. For now, this is just absorb this, that this is the mathematical function that will find the maximum between all these values that we're specifying, and we can specify a bunch of columns in here, and that'll be fine. So if you look here, there's 1, 2, and 3. If we do a quick spot check for this column, the max length is 30. That's happened there. Between 24, 26, and 31, that's 31.2 there. So we can be fairly confident that our max length variable is doing its job. Before we continue, while we're on the topic of functions, SAS has a lot of built-in functions. SAS differs from R in the sense that it's a very closed system. You can't just go and download a package to do something else. In many cases, if you're looking for a specialized package, for example, to do a specialized statistical analyses, you will have to, for example, purchase the SAS Stat package to get access to that. But SAS is kind of a language where you're given a bunch of functions, you're given a box of tools, and you can't just go to the tool store and download another package or tool to help you with something. You've got to make it work with the tools you've got in your toolbox. You can write your own functions. There's something called proc FCMP. It's not important for SAS base. It's part of the advanced topics. You can write your own functions. There's something called macros. Macros are not functions. It is a text pre-processing language. It can be used very similarly, almost to what you would expect from a function, but they are not functions. So you can use all of this to kind of make your life easier. But for the SAS base exam, for a large part of your working career, especially your early working career, you would have to get used to working with what the SAS system gives you. Okay, gone off on a tangent there, but I think it's important to mention. Let's go back to our questions. Then we've got a bit of a silly calculation, but it's something. We're trying to calculate the volume of each fish. So we're going to take the length, the height, the width. So we're getting some cubic unit of something that is the volume of this fish. It's a very rectangular fish apparently. So let's do all of this in the same data step. They want us to call it fish vol. I set up these questions, so that's what I wanted to do, but I've forgotten what I wanted to do. We're going to use our max length variable, which we've just calculated in the previous step, times height and times width. And now an important thing to remember is you cannot make use of max length before you've actually calculated it. So you can't drop this statement before the other one, because it's going to say, well, max length does not exist at the time you're trying to reference it. Or it will simply say it's an uninitialized variable, and you'll get a missing value back. I think that makes perfect sense. If you've programmed in other programming languages, you can't reference a variable that doesn't exist at the time you're referencing it. So we're calculating the max length, and then we use max length in this calculation. We can run that, and we can now see that we've got a fish volume. So we can kind of easily quickly desk check this. So 30 times 4 gives you approximately 120, and if you multiply 120 by approximately 10 or even approximately 12, you should get somewhere between 1,200 and 1,400, which we have here. So we know that desk checking our calculation, we know that it more or less works. Okay, we've read in this data set, we've given it another name. Not just given it another name, we've created a new data set and written it out with a name that is based on another data set. So let's be clear about that. We've calculated the max length as was asked, and we've calculated the volume of each fish, of our very rectangular, very boxy fish. So we can proceed to the last question. Excuse me. And the last question is to sort our data set by descending volume. So we basically want the biggest fish first. Now that you could probably do that by weight as well if you wanted to. For now, let's use our variable that we calculated. And the way you would do that is use a proc. And now we're introducing something new, which is a proc statement. And a proc statement is kind of where you give SAS control. So the data step is kind of where we take control. We create new variables, we do things, we manipulate existing things. And a proc step is where you kind of hand off to SAS. And you say, okay, well, take this data step of mine or this data set, which I've created with a data step, and now do something with it. In this case, we want to sort our data step. So we're going to proc sort. Which data are we sorting? It's the one that's called myfish. And out we're going to put myfish sorted. We know that every proc has to end with a run. It does not have to, but it's good programming practice to put it in there. So up to this point, this should hopefully make sense to you. We're passing our myfish data as an input data set to proc sort. And we're expecting to get an out data set called myfish sorted. And the one good thing about SAS, because it's if you want to see something good about a closed and a proprietary system, is that it's controlled. When we get to other procs, like a proc means, a proc contents, a proc print, that sort of thing, they're all going to follow more or less the same syntax. So you're not going to get vastly different packages where, for example, in R, these parameters start with a dot because at that time that was what was decided and we're now sticking with that. And these new packages don't take their parameters with a dot as a prefix, etc. You're going to see a lot of structure and rigidity, which is sometimes good. This also fits in with what I mentioned yesterday about being more of a business language. You give SAS a data set to sort, and it sorts it. You don't have to worry about how it's being done or specifying a particular sorting algorithm or any of that. You hand it off, and SAS will give it back to you sorted. The question then becomes, what are we sorting by? So we know we're sorting by fish volume. So if we put in here by fish vol, that's going to sort it by default ascending. And we can take a look at that as well. If we run this, so we've got two data sets here. Just keep that in mind. If you run multiple steps, that's going to produce output. So my underscore fish, and we've also got my underscore fish sorted. You're going to have multiple data sets in output data. So you'll need to go and select it here. And so if we look at this now, we can see that looking at this fish volume, this one is 19, 23, 26.1, 26.5. So it sorted our output data set accordingly. But this is now ascending. We've been asked to do it by descending. And the way we would do that is simply to put the descending keyword in there. This keyword should be repeated. So if you wanted to do, let's say, descending fish volume, and then also sort by, let's come back to it. We can come back to it. So if we run this now, again, we need to go to the appropriate table. We can see that we've got 577, 573, 549, etc. So we've now completed what the exercise, what the assignment asked of us. We've calculated all of these things and we've sorted by descending volume. Something we can do is we can sort by multiple columns as well. So we can say, for example, and that length 1, length 2, length 3 is actually going to be very useful, because we can do something like this, where we say by length 1, length 2, and length 3, and note that you're not separating these with commas, you're just separating them by space. If you put a comma in here, then SAS will moan at you. So what I can do is I can just run this bit of selected code, because we've already got this in the work library, it's already in there. And now, because I'm not running that other piece of code again, it'll take me straight to this data set, to this table. And so what this piece of code does, because we said by length 1, length 2, length 3, is it will first go and sort length 1 by a specific value. It will then sort by length 2, and then it will sort by length 3. So I'm looking for a nice example. These are all exactly the same, so that does not help us very much. Here's a nice example. So if we look at these two rows here, we've sorted by length 1, and you can see that because it goes 13, 14, 15 until we get to 17. Now these two are the same. They've got length 1 as 17.5. And so when that happens, SAS goes to the next thing that we're sorting by, and that's length 2 that we've specified. So now it sorts 18.8 before 19. And if these two were still the same, it would look at length 3 and it would say, okay, well, you know, which of these is the smaller of the two. Something to take note of is that proc sort in SAS is, there's a word for it in computer science that I've forgotten. Stable, that's the word. So proc sort is a stable sorting algorithm, which means that if things will not be moved unless they have to be moved. So if these were, let's look at that other example. So these two are exactly the same. 11.3, 11.8, 13.1, whatever. Because these are exactly the same, they go together. But in the original data as well, 10 for the weight would have come before 9.9. So SAS preserves that order. It won't shuffle things around. It's a stable sorting algorithm in proc sort. If you wanted to add descending keywords, you would have to do so for each one. So if you do descending length 1, descending length 2, and descending length 3, that'll do length 1 descending, then length 2 descending within that, and length 3 after that. So if you take out this one, that'll do descending 1, descending length 2, and then ascending again for length 3. So just bear that in mind as well. That wraps it up for the exercise. The next slide, I think, is just what we're looking at next time. I think this is a very good start on your SAS journey. We've started with data, we started with proc, we've learned about proc sort, which is new, we've looked at comments, we're learning more about how we reference an input data set and how we output it on the other side. We're learning that we can daisy chain things from one data step to a next one, or we can take it from a data step into a proc, and we can keep working with that. And so next time what we'll be looking at is libraries. We're going to learn a bit more about libraries. We've been using the default one that SAS maps for you automatically when you start the session. So SAS help and work and those ones. We're going to be looking at mapping your own libraries. We're going to be mapping that to a specific folder. We're going to write our datasets out to that folder, which will store it permanently, so that when we end our session and we come back, our work is still going to be there and it's going to be preserved, unlike the work library. And then we're also going to look at a new proc, something called proc contents. And that's going to give us an overview of a specific data set, a specific library, or we can even look at an entire library and all the data sets that are within there. And that gives us a good overview of those objects as well. And we get to learn about a new proc, which is very useful. So that's it for today. If you have enjoyed this video, if you find it helpful, please give it a like. You're welcome to leave a comment. Share it with your friends if you think they can use it. And then probably until next weekend, because I probably won't have time to do the new episode during the week. Next weekend, I hope to have episode 3 up and available. Thank you very much for watching. It's appreciated. I hope you enjoyed it, and I'll see you next time. Cheers.